Let us now study electrostatic potential energy and electrostatic potential. Now let us take a big positive charge here. So let this be a very big positive charge. It's called as a source charge. Okay. Its value is given as plus Q. Okay. So this is a very big positive charge. Its value is plus Q. Now let us take a test charge here. Okay. The test charge value is also plus positive only. Okay, but we write as plus Q dash. Test charge is plus Q dash. Its value is also positive. Now we are going to bring this positive charge from one point to another point. Okay, so let's name this points here. So this point we can name it as say this point is R. This point is R. Now we are going to bring it to another point here. This point is P. Okay, so we're going to bring it from R to point P. Now let us see what happens here. Okay, so let this be like this way. This is the line here. Okay, we are bringing from point R to point P. As you go like this way, this is a positive charge, this also is a positive charge. Positive and positive will repel each other. So whatever force we give from this side, that will be repelled. No, so we are giving an external force. That external force must be repelled by the force due to the Coulomb, that is due to charges here. So we write like this way. Okay. So the F external, the external force that we give, that will be equal and opposite to the Coulombic force. Okay, so this will repel each other. Now let us see the work which is done. Okay, we are moving from one point to another point. Let's see the work which is done. So work is equal to, we know, force into distance here, distance between R and P. But now let me take the distance as a very small distance here, that is here, like take it as dr. Okay, we'll going to take small distances, then we can add everything. So work is equal to force into distance, so as F into dr. Okay, now we are going to add all the small distances, so you have to use integration here. It's a form of addition only. So this is the external force, write as external. This is a vector quantity force, and the distance also is a vector because we're moving from one side, one point to another point. So we're moving from R to P. So here the force will be less, here the force will be more. So lower limit is R, the upper limit is P. So lower limit is R, the upper limit is P here. Now let us see what is the potential difference here. Okay, for that let me take the potential at R, or the potential energy at R to be as UR, the potential energy at R, and the potential energy at P as UP. Now you see there will be more potential energy here because there will be more repulsion. So we write as UP minus UR. We're going to write the difference here. So let me write it here. Difference here. That will be UP minus UR. That is the difference in potential energy. That we can write as delta U. That will be equal to the work which we do. Okay, so I write this delta U instead of W in this equation. So what happens here? So we get here delta U is equal to integration of F external, the external force, into dr, vectors here. The lower limit is R and the upper limit is P. Then let us now see what is the external force here. Can we substitute instead of external force? Okay, so let's do that now. Okay, let me write it on this side. I'll draw a line here. Now what I do is, instead of external force, I'm going to write this thing. So we know that I can say, since the external force is equal and opposite to the Coulombic force, okay, that's a force due to repulsion of charges, and we know the formula F is equal to QE. So I'll write that here. So we have a minus in here, minus Q and E. But if you notice that the charge which is repelled is this Q dash, so I write as Q dash here. The minus sign comes from this formula here, not because of this charge. Okay, Now let us substitute this equation here. Okay, so let's substitute here. So what we get here is delta u is equal to integration of r to p, and instead of this external force we have this thing now, minus q dash e vector into dr. Okay, now q dash we can take outside, so what we have is delta u is equal to q dash into integration of minus e dr vector for lower limit is r to the upper limit is p. Now we're going to find what is the potential energy per unit charge. Delta u means the potential energy, and let's see the charge. So that quantity we write as delta u by q dash, that will be equal to this quantity, that is r to p, and q dash we shouldn't forget, minus e vector into dr vector. Okay, the whole thing divided by q dash. Now what happens, q dash and q dash will cancel. Okay, now if you notice that we have the equation delta u by q dash. This quantity is defined as a potential difference between points p and r. So there's a potential difference between points p and r. So the potential difference we write as vp. Okay, potential difference at p minus the potential difference at r, so vp minus vr, that will be equal to integration of minus e vector to dr vector from lower limit is r to the upper limit is p. Okay, now this one we can also write as delta v, or you can say this delta v, this r. Okay, so the change in potential difference is equal to integration of lower limit r to upper limit p minus e vector dot dr vector. It's actually dot product here. Okay, now let us see another concept here. Now let us take the source charge here. This is a source charge, that is plus q, and then we have the test charge at here. Okay, this is a test charge, that is plus q dash, but now you see this test charge is at infinity. Okay, so we bring it from infinity to this point here p. Okay, so as you bring from infinity to this point, some work we must do. That work is defined as the potential, electric potential at this point here. So let's see what's my electric potential formula. So electric potential at the point p, that is given as v. V stands for electric potential at this point p is equal to integration of minus e vector dot dr vector. But you see the lower limit is now at infinity, so write as infinity to the point here p. So we can take the minus in outside, so minus will go outside, minus of e vector dot dr vector from lower limit infinity to the upper limit is p. This shows the potential at p. Okay, now let us see, this is a thing called as electric potential. Okay, so what's the SI unit of electric potential? The SI unit of electric potential is given as volt. Okay, we have to come across in batteries and all, so they say volt. So how does the word volt come? It comes from the scientist name Alessandro Volta. Alessandro Volta. Okay, Alessandro Volta was the first person to invent the he invented the world's first battery.